Hi folks. Right, so we're going to look at bearings now. Now, a few key points before we do any work with bearings, and these are so important. If you've got these kind of sorted, you shouldn't have too many issues with bearings. If people slip up with them, this is normally where, okay? So first key point, always measure from the north, okay? When we're looking at bearings, and this is what I'm talking about when I mean bearings, questions a bit like this. So find the bearing of B from A, okay? When we're talking about bearings, we always measure from the north. And that is mostly because people used to use compasses a lot more than they do now. I don't mean compasses, what we use for drawing circles with. I mean directional compasses. And they always showed you where north was. So if you could always find north and you knew your bearing, you could navigate towards it. So we always measure from the north, okay? So quite often in exams, they'll kind of give you, like I've done here, they'll tell you which way north is, okay? If they don't, it's up, generally speaking, on an exam paper, but they do normally give you a direction of north. They should do anyway. Next thing, always measure clockwise. That's really important. Okay, so when we're measuring our bearings, we're starting at north and we're seeing how far we're going clockwise. So that's the direction of the clock, okay, off to the right. Really important. They're the main two things, really. Now this one, take care with the word from. And this last one here, visualize as real world problems. These kind of come together. These kind of help each other out. And a lot of this comes down to the language, and that's certainly where I slip up, and I still use this last one all the time now. I still have to visualize these kind of questions. There's nothing wrong with doing that. It makes it a lot easier. So the word from, okay, so just looking at this question here, find the bearing of B from A. Okay, so you've got to think, okay, I'm starting at A, I'm going from A to B. Okay, so what's the bearing from A? I'm starting at A and I'm going to B. So almost think, okay, I'm a ship. Ships use bearings a lot. Here's a ship at A, and I want to know what bearing ship B is at. Okay, so I'm going to calculate this bearing. We're going to figure out how to do this in a moment. But these here, really important. So thinking of it as ships, as people standing in a playing ground, something like that, playing fields, anything that just helps you picture it as a real life problem, because it makes it a lot more easy to understand. Okay, so grab those notes in your book, really important, make them stand out. And I mean, that is basically everything you need to know about bearings. We're going to practice some, but these are the main points. You shouldn't have too many issues if you're following these very carefully. Okay, so I've got two questions on here. Okay, so I'm going to look at this one first, this pink one. And I said, find the bearing of B from A. Okay, so we're starting at A, we're going from A. So be careful, try and say it out loud a few times. It certainly helps to just get your head around which direction you're going, because it's very easy to go the wrong way. And so we're starting at A, and we're going to find north from A. Okay, so I've drawn it on here, arrow going up, telling N for north. Okay, and we want to know what angle we have to turn from north to be going in the right direction to get to B. So the first thing you need to do is to grab a ruler or a straight edge. You don't particularly need to measure it on this one. And you're going to just join up A and B. Okay, I'm going to use a different colour pen so you can see which is my work. Also, I did buy new pens on Amazon and I'm desperate to use them all. They're lovely ones, they're Papermate ones. I'm really enjoying them. So we're going to find out this angle, okay? We want to go from north all the way and see what angle we have to turn to get to B, okay? And all you've got to do is measure the angle. The tricky part of this is making sure that you're measuring the right angle, the correct angle, okay? So line it up there. We've done some work on angle measuring, should be happy with those. And I thought I'd measured these out beforehand, perhaps not quite as well as I thought. So we're starting on the outside scale all the way around here, which is actually 69 degrees. Okay, I thought I'd got a nice round 70, but I must have mislabeled it. So 69 degrees, that's your bearing, okay? That's the answer to the question. So we'll try another one, a similar one down here, the bearing of A from B. So this time we're starting at B, we're going from B. We want to know what do we have to turn from the north at B to be going in the right direction to get A. Because if you picture this as being ships in the ocean and you get that bearing out by a matter of 1 or 2 degrees, you could miss it by a really long way. It's really important you're accurate. Okay, so we're going from B to A this time. So we're going to start at north again. We're going clockwise. That's this way around here. Make sure we forgot to join them together. Joining them together just means that you've got a lovely nice line to help you with your reading. It makes it a little bit easier. Okay, so lining that up there, and once again on the outside scale, starting at 0 all the way around to 110. Okay, don't mistake that for 70. We're on the outside scale. 110 degrees. Okay, that's the bearing you've had to turn. Okay, so that's the first type of question you're likely to see. Normally worth a couple of points. Okay, shouldn't have too many issues with those. Now then, what about these ones? Okay, a little bit different. It's the same principle, but absolute same principle, but we have to perhaps put another step in with these. So now we're going to find the bearing of A from B. Okay, so we're going from B this time. We're starting here, B's here. We want to find out what do we have to turn to get to A. But you must remember we're turning clockwise. And it's so easy here to go, okay, let's measure this angle, because that's nice. But that's not going to work. Okay, we have to go, well, let's just join them together first. So we've got our line. Let's join A and B up together. Okay, we have to go all the way around here. We have to go clockwise every time. Okay, and the reason it's clockwise every time is because it's consistent. If I told you to just turn by 40 degrees, which way are you going to go? Okay, you could go anti-clockwise or clockwise, and it could have been an absolute disaster for the shipping industry. So we always go the same way, and that just takes out any confusion. Okay, so we need to measure this angle. The problem is my protractor's not big enough. Okay, now I do have another video on here on YouTube about measuring angles that are bigger than 180 degrees. Have a look at that if you need a bit more of an explanation, but I'm just going to briefly go over it now. Okay, so I know that there's two different ways of doing this. Okay, and the one I'm going to show you right now is angles around a point. If I know that the angles around a point must sum up to 360 degrees. Okay, they must sum up to 360 degrees altogether. So if I know what this little bit here is, if I know what that is, I can subtract it from 360 and it should tell me the rest of this. Okay, and that one fits on my protractor, so I can just do that one. Okay, so lining up there, this time I'm on the inside scale. Let me see, I'm on the inside now, all the way around to 65, 66, 67, 68 degrees there. Okay, and these do tend to be non-calculator, so try and get used to doing these. They're quite short sums, but these sums without a calculator. If you're going to do 360, subtract 68. Okay, and for that we're going to have to just do a bit of shuffling around up here. Okay, so we're going to get 2 there. Take from there. Okay, 9, 2 subtract nothing is 2. So our bearing is going to be, so I'm going to pop this one over here, 292 degrees. Okay, that's what that angle is. Don't be thrown off. I've just realised something that I've done here. I don't want you to wonder why I've done it. I've drawn north on here twice, and on this one I only drew it once. Don't worry, there's nothing wrong with that. I drew it on here and realised actually I kind of needed it on here because this is where I was measuring. You'll be given one of them in an exam most likely. If you need to draw another one on, make sure it's parallel, because they're both going the same direction, so they will be parallel. But if you need to have another one here, that's fine. Okay, there's no special reason why there's 2 there, 1 there. It's simply I drew it in the wrong place and just did another one. Right then, so this time the bearing of A from B. The bearing of A from B. So we're going from B to A. Now, this one is a nice one because actually, if we remember our rules of parallel lines and angles, we can actually do it without a protractor. And I'm going to show you how to do this one without a protractor because they've already given us this information. Okay, you might wonder how that is helpful. I'm going to draw my north on here, look. Just draw my north going up there. Because we're going from B, so I need to be able to measure from north on B. Now you might wonder, what's that got to do with this? Okay, because we're wanting to look at these angles, aren't we? But because these are parallel lines, we know that these are co-interior angles. Okay, I've got a video on that. Have a look if you need a bit of a reminder about those. co-interior angles sum, that means add up, to 180 degrees. Oh, I put an S there. Sum to 180 degrees, okay? So because we've got two parallel lines here, joined up with a straight line, that means this angle and this angle have to add together to get 180 degrees. Okay, so we can do, I'm going to write out the calculation simply because we always have to show working out, and even though you could probably do that in your head, you've got to show what you did, because if you get it wrong, it happens under stress, they can see what you were going for, okay? So 180 subtract 70, 0, 1, 1. Okay, so 110 degrees there. Now don't forget, we need to now measure around here clockwise. And from what we did before, angles around a point equal 360. So if we do 360, subtract 110. 360, subtract 110. Always just write down what it is you're doing. 5. I nearly wrote 450 then. I thought that can't be right. I added by instead of subtracting. So 250 degrees there. Okay, 250. Let me just put that to the side there. 250 degrees. You'll obviously be given a place to put your answer in. So that's the bearing of A from B. Now I'm going to show you one more. These cover a lot of what you'll need to do on a foundation paper, but there's one more, which is quite an interesting one. It's worth a few more points, and actually the work's no more tricky than what you've just done. You've just got to combine a couple of different ones together. Okay, so we're told here, and actually I do think a lot of the problems people hit with this kind of question is simply reading it. It's wordy. You can look at that and think, no, can't do that. It's very similar to what you've just done. Just don't get overwhelmed by the reading, okay? Get your highlighter, highlight the key words if you need to. So we've got location C is on a bearing of 140 degrees from A. So we've only got location A and B on here so far, but they're talking about location C, and it's 140 from A. So we're going to go from A to C, but we don't know how far away it is. Let's read the rest of the question before we do anything else. So the bearing of C from B, so from B to C, is 260 degrees. And now we need to find C. Okay, so I quite like these because once you've done the first two bits, it just kind of falls into place. So let's start at the beginning here. Location C is on a bearing of 140 degrees from A. They've not told us how far away it is, but they've told us which direction we need to go in to get there. So let's find it. 140 degrees. Our protractor. So we're going to, again, going from north clockwise, starting at 0, so outside scale, all the way around to 140, which is, I'm going to pop a little dot. And I'm just going to pop, because I don't know how far away it is, this C, I'm just going to do a great big line all the way down to there. Okay, C is somewhere on that line. Okay, because they've told us it's at this bearing. It's 140 degrees from A. That's the bearing. They just haven't told us how far away. So somewhere along here is C. We also know, though, C from B, so coming from B to C, is 260 degrees. Now, the best way to probably do this is the same way we did on the last questions. Do you remember when we did these here and we considered that it was 360 for the whole thing? Because of course 260 is bigger than what I've got on my protractor. Okay, so what I'm going to do is I'm going to do 360 subtract 260, which really didn't need to be written out, I don't think, fully, but there we are, 100 degrees, and that tells me what the leftover up here is going to be. Okay, so if I put 100 degrees here, then I'll know everything else left is the 260. So on the inside scale now, 100 degrees is just here. Okay, and if I join that to B, okay, I could have done with a bit of a longer ruler there, couldn't I? There we go. What I've got here is 260. Okay, 260 degrees there, and I've not written this one. This was 140, wasn't it? Okay, and you've essentially done at this point because location C is on this line here somewhere, and it's also on this line here somewhere. So we know location C must be where they cross. Okay, so there is your location C. So Not much more tricky. There's not loads more work than on the last questions. It's just perhaps a little more tricky to kind of interpret what they're asking. And that's why I said on my first set of instructions, be really careful with this word from. Even now I still have to say that out loud, or, you know, kind of consciously kind of say it in my head. Don't start sitting in your exam saying from. I'm not sure that'd go down very well. But, you know, kind of consciously say that word in your head. Really notice that word. And again, visualizing it is a real word problem. You know, these are probably, you know, potentially 2 ships. Here's a 3rd ship, and they perhaps are looking for that. It's a location tactic here, okay? I think that's the last one I've put on there. It is. Okay, so hopefully they've been helpful. Take down some notes if you need. But I have sent you some sheets to have a go at. The first one is full of lovely questions like these ones. Okay, I've also sent you the answers to help you mark them afterwards. Please don't just look at them in the first instance. That's not helpful. That's useless. If you get really stuck, have a look at 1 or 2, see if it moves you in the right direction. If it doesn't, let me know. I can send some more work over, some more help with those. The second ones are a little trickier. It's these sorts of questions, okay? So you're going to be kind of compiling different bits of information. Have your absolute best go at these ones. If you struggle with them, let me know. I'm happy to put more videos up showing those specific questions if a few people are struggling with them. If you're the only one, don't worry, I'll send you one as well, okay? Right, take care with those, please, and let me know how you get on. Thank you.